Hey, it's Greg. How are you? So, I'm going to give you some hopefully helpful hints. Ooh, alliteration. Hopefully helpful hints on review number 4. So, chapter 6 is about using table A2 and the z-score. So, there is a normal distribution. You would always put the mean in the middle. So, the mean is equal to 925. And then the question is saying, for a single leatherback turtle, what's the probability that that turtle weighs over 1,000 pounds? So 1,000 would be over here, so it'd say x equals 1,000 pounds. Over means to the right, and then you use the z-score. So that is the score minus the mean divided by the standard deviation. So the 1,000 would be the score, 925 the mean, then divide by 56, and then look that up in table A2. Now the difference with this one is it's 7 leatherback turtles. So you basically do the same thing as number 1, except when you do the z-score, it would be the average, so that would be the 962 minus the mean divided by the standard deviation. And then what you do with the 7 is you divide by the square root of 7 on the standard deviation. And when you type that in the calculator, make sure that you use parentheses so the calculator knows this is the numerator and this is the denominator. Now part C is basically like part A. You would put the mean in the middle. And since the mean is 925, that means that 800 would be over here, 880 would be over here, and then I'm asking for the area in between. So you would do the z-score for the 800, you would do the z-score for the 880, look up the z-scores and find the probability in table A2, and then to find the area between those, you subtract the two answers. In order to be in the top 7% is basically saying there's a z-score right here, which I don't know. This is the top 7%, which means that this side is 93%. And then you look in table A2, not at the side, but in the middle of the table until you find whatever's closest to 0.93. And then you find that little z-score and you put that here. After that, you would do the score that the formula that says x is equal to the mean plus z times the standard deviation. And then this little happy face would be what you put right here for z. So this is chapter 7 using one proportion C interval. And so for this information, this is about the smokers. So that is n equals 485. And then how many have been divorced? So that is x equals 238. And then you can do the one proportion Z interval, and it will tell you the two numbers. Whenever you do proportion intervals, it has to start out with 0 point something. It can never be over 1.0. So you do that for the non-smokers as well, and then compare them. So just see, do the percentages for this one look different than the answer you get for this one? If so, which one's bigger? So this one is also saying use a confidence interval, but this is about the mean. So we have n equals 36, the average 11.79, and the standard deviation 0.21. So the soda on the outside of the can says 12 ounces. 11.79 is a little bit less than that. But is this enough to prove in general that it's going to be less than 12? Because there is some variation from can to can. So then you could use the the t interval, enter this information, and you'll get the two numbers for the confidence interval. And then at the end, answer the question, is Pepsi filling them with less than 12? So if both of these numbers are less than 12, I would say yes. If they're above 12, no. And if there's a split, then you could say we can't conclude because one side is less than 12 and the other side is greater than 12. And then the confidence interval for standard deviation. So this one is not in the calculator. You need to do this formula. So first of all, the interval looks like this. So it's for standard deviation squared, goes in the middle. Then you put n minus 1 times the s squared, and that would be this 9.8. You do the same thing on the left side, and then you use table A4. And for table A4, you need degrees of freedom, which is n minus 1, or in this case, that would be 47 minus 1. So you look up those two critical values, and there would be chi-squared, they're both called chi-squared, and chi-squared on the right, you actually put it on the left, and chi-squared left, you put it on the right. And then at the end, take the square root of everything. Sorry, that wasn't very neat, but you get the idea. And then at the final is the conclusion. Is 15 within that interval? All right, I hope this helps. Talk to you soon.